actually, I believe one person on the phone, if they can introduce themselves.
I'm Deborah Hurley. I'm a fellow at USS affiliated with Brown.
Deborah Hurley.
I hardly understood anything.
Okay. But thank you for joining us. So.
Yeah, sure. Okay, so thanks everyone for coming. I'm Samer Hassan. And well, if someone is gonna tweet, I would recommend this hashtag, so we have all the same hashtag. And I'm gonna try to make the point in this talk that blockchain is a new technology, as we all know, that is bringing new potentials for technology to regulate human behavior. So we already had that, but blockchain is taking it to a whole new level. And I'm going to try to go slow through this explanation. So what do we mean by regulating human behavior, right? So Lessig, a professor of this university, actually, already a while ago in the 90s, drew this, the pathetic dot theory, which comes to say that we are basically that point in the middle, and there are several forces that constrain our behavior. So the most obvious would be law, that obviously when we are trying to do something, if there is a law against it, we are compelled or constrained in our actions somehow, because we are going to be punished afterwards. After the fact of doing it, there will be a threat of being punished. There is a judiciary system, there are police forces that would constrain our action somehow. There are also social norms that are not defined by a state or constrained by a police, but by the community. So we are, in the same way, constrained by these social norms that define or constrain somehow our actions. Of course, we can act against them, but no one wants to be marginalized by their own groups or community. So we would be reluctant to do so. The same way the market pushes us in certain directions, like the laws of offer and demand, even though they are not state laws, they are constraining what can we purchase, which products or services, or even what is accessible to one person or not. And finally, we have the architecture. By architecture, Lessig means the world that is constraining us. In the physical world, we can understand nature as a powerful force constraining our actions, right? So if I want to move forward and there is a sea, obviously, or a river, obviously there is a constraint that nature is putting on my movement. Similarly, as humans change our world, we can have the urban setting limiting our actions. So for example, if this room was structured with fixtures all looking on this direction, regardless if I put a rule saying that it's obligatory to look at the slides, you would all be compelled to do it because of the setting that you are embedded into. So we can see that technological artifacts are political. They have social and political consequences. There is a myth saying that technology is neutral, that it only depends on the use of that humans, the way humans use a neutral tool, but every technological artifact has embedded social and political consequences within it. Of course, you can try to use it in different ways, but it's clearly pushing you in certain directions. Similarly, when we are talking about computers or about the internet, the laws that govern us are not so much of the natural world or of the urban setting, but of the code running that we are interacting with. In that sense, code is law, according to Lessig. Code is the law in cyberspace, is the regardless if there is an actual law defining our behavior or not, we are constrained by the possibilities of such code. And code is something quite special and quite different than the natural architecture or the urban setting that we are embedded into. Code has special qualities that make it as it is. For example, the cost of reproduction of code, as we all know, is very low, and it can be said, we can say that it has zero marginal cost of reproduction. So if I want to copy and paste a file in my computer, given the cost of the infrastructure, of the hardware infrastructure, it has zero cost. But the same file, I can put it in a peer-to-peer sharing network where it can be copied thousands of times, and for me, it has zero cost. If I wanted to do the same with a chair, a physical chair, I mean, we see clearly that there is a high cost of reproduction, of copying in the physical world. That doesn't happen with code. The barriers to entry are very, very low. So it's very easy to write code. It's very easy to deploy code. We don't need factories to build code. Everyone with a computer can do that. It's very adaptable. So nowadays, I can pick some code that is available around there, change it a bit, fork it, mix it with other pieces of code. And I don't need to know that much to build everything from scratch. It's very easy to adapt and to reuse. And code brings regulation or constraints that are ex ante. That is, before the fact, I'm already constrained. Typically, law would be ex post. That is, it acts after the fact. After I do something wrong according to the law, I am punished by it. Code stops us from doing it in the first place. When it's not providing a possibility, we cannot go beyond the possibilities of code.
Samir, sorry, I just want to check. Is
Sure.
the mic thing on, the machine?
Oh. I have no clue.
Just want to make sure. Okay, yeah,
It's-
sorry. Just want to make
no
sure
problem.
Actually
It's
recording
fine.
audio.
Yeah. So, sorry.
Sorry about that.
No problem. There are several ways that we can understand code regulating our behavior. So for example, code could enforce a given law. Like we can see the most famous example is with copyright law. So copyright law that comes from 19th century and even before it's trying to limit the possibilities of reproduction of cultural works, like, for example, a book or a movie, that when they were a physical object, it required a high cost to do these copies. When they become a digital object and you want still to apply the same copyright law, this law clashes with this specificity of code that we were talking before, this zero marginal cost of reproduction. So in order to make sure that copyright law is respected, code has been developed to enforce it. So the digital rights management, or DRM technologies, they try to impose constraints on code, on the digital works. So for example, music in my iPod cannot be copied outside of it, or a PDF cannot be printed because it shouldn't be reproduced, and stuff like that. That is limiting the behavior of humans while interacting with this digital work. In the same way, we have seen code used to circumvent the code that is enforcing certain laws. So we would have cracks of these DRMs. We would have jailbreaks of iPhones or Androids. We would see the DVD encryption algorithms that restrict it by region. So this DVD works in America but doesn't work in Europe and stuff like that. It was cracked with the CSS code. We have seen also code developed to bypass certain laws. So, for very famously, Napster challenged the copyright laws and the musical industry, providing a platform where songs could be shared. And when the legal framework was changed in order to crack on these central servers that allowed sharing, peer-to-peer technologies emerged. So there is no central actor that you can punish for this sharing. But also code has created new rules that have absolutely nothing to do with existing laws. So for example, in this peer-to-peer sharing example, users using peer-to-peer sharing technologies are compelled to upload and not only download by design. So regardless if I want to or not, when I'm running a BitTorrent client, for example, I am sharing chunks of what I am downloading automatically. So it's making altruism embedded rule in the network, regardless if the user wants it or not. The same way, we see graphical user interfaces constraining our behavior, as in, for example, Facebook is pushing certain rules that they have defined in order for users to interact, and we cannot go beyond that user interface that is constraining our actions, and that has absolutely nothing to do with existing laws. So blockchain enables new types of regulation by code that were not possible till now. In order to make this point and convince you about that, we need to go a step backwards and actually explain properly what's blockchain and why is this different. So I will try to give a quick blockchain 101 crash course right now, so we can be all in the same page in order for a fruitful discussion, I hope. So blockchain's origins are clearly in Bitcoin. Bitcoin is a digital currency or cryptocurrency. It all started with a paper of Satoshi Nakamoto, which is individual or collective identity, which we don't know who's behind it, with an actual kind of a scientific article or a paper on cryptography mailing list in just a few years ago, like 9 years ago, where it was proposing this currency. Bitcoin has been very famous, especially because of this, because it's the first time that an actual decentralized digital currency or basically the most famous digital currency right now has actual value, monetary value, that keeps growing, and it's around more than $1,100 per Bitcoin right now. So why is that? How is this working? And what makes Bitcoin special? So Bitcoin is a digital currency and peer-to-peer payment system whose management is completely distributed. That means there are no central entities. There is no government, there are no banks, but there is no company controlling certain servers, nothing as such. There are, its transactions are secure, are cryptographically secure, and all the transactions are public, and they can be verified computationally. It's not anonymous, as many state, but it's pseudonymous. So the identities that anyone can create as many identities as you want, and you can do certain statistical analysis of these identities. You can try to deduce some stuff, but definitely is not linked to your real name. So it's definitely much more anonymous than what a bank transfer would be. For obvious reason, this has benefited multiple actors. I will not get into that. But I would want to get into, okay, why Bitcoin is special and why cannot we do what it does in another way? For example, if we wanted to do a digital currency in the classical way, a centralized digital currency using a server, what would I need? So if I want to create a new currency called Samcoin, because I am very egocentric and I choose my own name for the currency, as many have done. If I want to have this Samcoin currency in my own servers, and I want to convince Jean to use it, for example, what do I need to implement? What software should I code in this server that I own? Okay, at least it should have a ledger, like the accounting of, I mean, each one has to have, like Jean should have an account in my system saying how much money it has. And every time Jean does a transaction, it should record in the ledger the change in money and the transfer, right? So going to another account of another person and so on. The problem with this is that I can obviously tamper my software as I want, and Jean would need to trust me with his some coins, right? Ideally, this would work smoothly. I wouldn't need to, I mean, Jean wouldn't need to worry about his currency and he would be able to use it transparently. Of course, this is very problematic because I am the only one that defines the rules. I am the only one that controls everything. And Jean has no privacy on his transactions because I can see everything in my computer, in my server, right? And if I want others to accept some coin, I should convince them that I am trustworthy, which might be pretty complicated, right? And this has a lot of implications, centralizing, I mean, for privacy or for, well, I will not get into that, right? All the implications of cloud infrastructure, but applied to an economic system that it can go to another level. But we could try to do it decentralized. So these are types of centralization. A basic way of explaining how my system would be the first one. It's completely centralized, and all the users should be using my system if they want to use it. A second degree of decentralization would be like with hubs or super nodes, like kind of a federated network, like email works today, for example. And third, we have a peer-to-peer, completely distributed network. So what would we need for making a digital currency peer-to-peer, completely decentralized? Okay, we can implement that in multiple ways. And for example, we would still need that ledger, and we can put pieces of the ledger in different nodes, and they can synchronize from time to time parts of the ledger. So the network as a whole has the ledger, but no single node has the whole thing. But that brings multiple problems. Especially, there was a big issue with the double spend. Like, no one guarantees that one node is that, for example, one node has 100 units of the currency and spends twice this amount to two peers in the network that are very far from each other. That's very problematic because as I cannot know with whom I'm transacting, I don't trust everyone in the network. It's open to cheating, basically. So what Bitcoin tried to solve is this issue of double spending. How, basically, let's not trust anyone and let's put a copy of the whole ledger into every node. So all nodes have a copy of all the ledger, all the transactions from the beginning of time until today. So every Bitcoin node has all the transaction, the history of all the transactions. And this is, let's say, read-only history. We cannot modify or tamper this history because it's cryptographically secured, let's say. And we can only append new transactions to it. So we only have to validate the last transaction, the last group of transactions, and add it to that huge ledger. The metaphor of Bitcoin, in order to confer it value, is gold. So as gold, they defined Bitcoin, Satoshi defined Bitcoin as scarce. Gold has value because it's scarce. If it was very, very common, it would have much less value. So as we can define Bitcoin as however we want, because it's code, Bitcoin is defined, this is the growth function of Bitcoin. So it's basically, there are less and less Bitcoins in circulation. Not less amount, but the acceleration of growth is decreasing with time until there is no more new currencies. Like the monetary mass would be eventually stable, right? The monetary mass of all the Bitcoins, which is around 21 million in like 15 years more from here. And the same way as gold, how can we create gold? Well, we go to a mine and we search for gold, right? Like in the West, in America, it used to happen, right? So here, the mining, what they call mining, is a task that is needed in this network, because in this network, we need some nodes to do the work of verifying the transactions and appending them to the ledger, making sure that only like this transaction that I do to Ying is appended only once, and I don't send the same amount of money to two people, and there is an inconsistency, right? So in order to do that, we required computational work that the miners do. These miners, special nodes in the network, anyone can mine and try to verify transactions, and eventually they are rewarded from time to time with a Bitcoin that they can find after they have mining in the mine for a long time. So they try to incentivize or pay them their work of maintaining the network. Okay, so more or less we can understand right now what's the blockchain. The blockchain is basically the technology that makes Bitcoin possible. This synchronization mechanism or structure, architecture, that it's trying to maintain this database that is replicated in a trustless peer-to-peer network. So it's a distributed database which a quite complex synchronization mechanism. We have seen since Bitcoin came, we have seen multiple forks of it. Bitcoin is an open source project, so anyone can take it, modify it, and launch it. For example, I could create my Samcoin, just forking the Bitcoin and modifying certain values and launching it. And this way, there have been a lot of altcoins, alternative cryptocurrencies. Too many, actually, because anyone can do that, obviously. But this is not as interesting, at least for the matter of this talk, this is not as interesting. Of course, after the financial boom, there have been other applications. So very quickly, on top of the blockchain, we have a Bitcoin, but we could have, for example, a very early project that was BitMessage, trying to send a kind of an email over the blockchain. So I can use the blockchain for recording cryptographically secured messages, so only the person that is destined would be able to read it. And others would be able to, no one would be able to read it, but we have a shared, distributed record keeping of these messages that are all encrypted. The blockchain is renewed every once in a while because this is too much information to contain. But anyway, we have like a distributed Dropbox where one person could store data from other people. We have communication on social networks or stuff like that. We have other small applications that are emerging over the blockchain, and a lot of startups, obviously, right? And we have Ethereum. Ethereum is more like a platform where other apps can run on top. It's basically abstracting part of what you have to do, abstracting the blockchain, providing you a programming language to interact directly with the Ethereum blockchain. And Ethereum provides something that it's interesting for the matter of this talk. And now I come back to where we were. Ethereum provides smart contracts. What's a smart contract? A smart contract, it tries to emulate traditional contracts, as understood as a voluntary agreement between two or more parties that is enforced by law. These contracts that are smart, like we have smartphones or smart cities, now we have smart contracts. These contracts are trustless, that is, I don't need to trust the other person that, or the other entity that signs the contract, and they are self-enforcing. So I don't need a judiciary system or a police force to act upon, to make sure that the contract is enforced. It is self-enforced by code. So it is very efficient. It reduces a lot the costs, for example, of negotiation or of verification. It is not ambiguous because it's written in a formal language, like it's code. And it automatically executes its terms. We can think of a vending machine as a smart contract. Yeah, because it's trustless and self-enforcing. It's not non-ambiguous. It's very clear what are the terms of the contract. It automatically executes its terms, and it reduces a lot the costs of negotiating or interacting with a human in order to buy food, right? But we can also see Bitcoin as a smart contract. The whole network of Bitcoin, in the end, the governance is technical. The governance of all this system, in the moment that I'm using it, I am accepting its rules. I am signing its contract, let's say. And it's non-ambiguous, and it's automatically enforced. When we are talking on the to embed smart contracts on the blockchain, we are talking about small, well, not necessarily small, snippets of code that are deployed on the blockchain. So they are executed by the network of distributed nodes. And where are them, or how? I mean, because typically we understand deploying code on the web as there is someone that controls a server that owns that code somehow, can turn it off or can modify it, right? Here is different though. Here this code can be autonomous. That is independent from any third party to operate, even independent from its creator even. And then if the creator doesn't add it to the code, it's potentially not controlled by anyone. So I release the code and it's there for anyone to use it, for good or for bad, whatever. We can go, and now I will put some examples, but we can go a bit further and, for example, think of complex smart contracts where multiple parties can interact. That is, we could have a distributed autonomous organization. What would that be? Okay, that would be a self-governed organization which is controlled by this set of rules embedded in its code. This code is incorruptible because I cannot tamper with the code of an autonomous entity that is deployed there, right? So it would be autonomous. independent from its creator, unless the creator embeds a dependency on the code. It would be decentralized and therefore decentralized in a peer-to-peer manner, and therefore, unless I program a kill switch, it can be unstoppable. It cannot be switched off like I could do with a server, with a web service. And it can be even self-sufficient. It can even gather resources and spend resources. Now I will get into that. So for example, we can imagine, Jean, I will use you as an example. So if I offer you a contract in which for some of your computing power, I will give you 0.1 Bitcoins a month, which is like $100. Would you accept?
Sure.
So Jean Identity signs this smart contract, right? With this DAO, with this distributed autonomous organization that promises this, right? Promises in exchange for some computational resources, promises a salary, right? And if, for example, I ask you for a bit of your hard drive and I pay you another 0.1 Bitcoin a month, would you accept?
Sure.
So now Jean is making like $200 a month. Of course, it can be Bitcoin, it can be any cryptocurrency. I'm not getting into that. However, in the code, there should be a way in which the DAO makes sure that if Jean tomorrow disconnects, there would be some kind of safeguard, right? So I would ask you to do a deposit of, for example, 0.2 Bitcoins per contract. In the beginning, you put this deposit, and you see in the code that as long as you keep it, you will be returned. You will have it in the end after, let's say, 1 month, 1 year, whatever. So you know that the DAO is not playing with you, right? But what if in the DAO there was code that said that its owner, Summer, can modify it whenever that you want, whenever Summer wants, right? Would you be willing to sign that?
No.
Why not?
Because I can't trust that you won't go back on your word.
That's the point, right? As long if it's not fully autonomous, people would be more reluctant to sign such an agreement, because I can perfectly, you put the 0.2 Bitcoins, I modify the code, I take it, that's it. And you don't receive any salary or whatsoever. So this autonomy is actually a feature in this context, right? And we can go a step beyond this. So for example, now, Jean, I will offer you to develop software for the DAO. And in a certain project with certain constraints, the DAO can automatically check, let's say, because it's a bit more complex than this, but let's say that the DAO can check if you are committing code to a certain GitHub project or whatever, or equivalent. Would you accept for, let's say, 0.5 Bitcoins a month?
Sure.
So then Jean is hired by who? Is hired by me that I developed the DAO? No. Is hired by a company? No, neither. Jean is hired by a weird software code that is running somewhere, but its code is uncorruptible, like Jean can't trust the code, but at the same time, the context that typically applied with hiring someone would apply to Jean or would not. You know what I mean? It's like fuzzy, at the least. This DAO is hiding Gene, but can also sell services. So for example, there can be another DAO or a human that pays this DAO for a library that is coded. And then the central DAO would search for developers for that library and pay them and maybe take a commission. So this code can accumulate currency. For what? We don't know. The code would say. But what I mean is that this DAO can suddenly possess monetary currency. They can sell services. They can hire services from entities or machines alike, or sorry, humans and machines alike. This has multiple implications, okay? For example, if we think of the Internet of Things, okay, these smart contracts or DAOs, they live kind of in a walled garden, so they interact within the blockchain, but they cannot interact outside of it. They cannot check the internet or the physical world. For that, we need someone or something to be taking data from the world and putting it in the blockchain so these entities can actually read it or react to it, right? So, for example, we could think of a hardware sensor that is taking the temperature of this room and recording it every hour on a blockchain. So that would be we call them oracles, a hardware oracle that is recording in the blockchain the temperature of this room, and then we can do smart contracts that take into account this information, right? The same way we can have an oracle like taking the data from the commits in a project, in a GitHub project, and recording it into the blockchain. What are the modifications? So the DAO can track if Gene is doing his work or not in this specific project, right? We can also think of smart property like devices that check the state of the blockchain, read it, and react to it somehow. We say in the blockchain, nobody knows you're a fridge. That is, you don't know if you're interacting with a human or with a software every single time, right? Because we can perfectly imagine a fridge that checks if it has milk or not, and makes it has Bitcoin or any cryptocurrency, and makes the purchase with another DAO controlled by a supermarket. So suddenly someone appears in your door with the milk that you needed because your fridge asked for it, right? It's actually funny, but it's not there are prototypes of this already working. There is a lot of investment on this. This is not science fiction. This is actually happening now. Like the example of the fridge is, it was done by IBM and Samsung, I think. So, if we think of a smart property, we can easily think of a car a smart car that only reacts, like this car is reading a certain blockchain, and only starts if the owner has a special cryptographic token, a special cryptographic key, right? So, and that key can be recorded, like it's kind of a special token, like instead of a currency, we have a special token that is in the blockchain, and that if my identity has this token, I can start the car, and if not, I cannot. So I can easily think of Gene interacting with a DAO and buying the title of that smart car, or the DAO owning that car. Would the DAO own legally the car? Well, not, but regardless, still, you cannot run the car without the key. And the DAO has a key. So you actually need to buy it from it if you want it, with the rules that the code of the DAO defines. So in practical terms, regardless of what law is saying, who is owning the car, right? So we can think of law turning into code with all this potential that I just throw a glimpse on. Blockchain code is still code, so it still has very low barriers of entry. The cost of reproduction is nearly zero. It's very easy to adapt it. It's still ex ante, so before the fact, it's already constraining our behavior. And this is actually a trend that is happening right now. Law is progressively being more and more encoded. The same as with the DRM example, it's happening more and more. And the blockchain just boosts this trend much more. And in fact, these smart contracts, their primary function is to replace legal contracts. This is how they were designed. So we can perfectly understand blockchain as a regulatory technology that is used to define legal provisions into code, to incorporate them into the code, and to enforce them, regardless if there is an actual law behind it or not. Of course, this has multiple issues. So we understand the language in which laws are drafted. Our natural language is ambiguous and is flexible. And it's good that it is like that, right? Because then it's applicable case by case. And we have the interpretation of a judge that can take into account all the factors that are that matter in that case, and a more or less generic law, and apply it. So the law doesn't need to foresee all the cases. And very frequently it does not, because the human behavior is very complex and unpredictable. So the judge is there to understand if this case is equivalent to this other case and take measures upon that, right? In the case of code, such laws have to be defined in a strict and formalized language, which predicts and at least foresee most cases, because it has to have very precise conditions in when it has to be executed and when it does not. Which, of course, has multiple implications. Law, at least in when we are talking in a democratic context, they are created through a democratic process that we can criticize more or less, but at least there is a process that is public, that is more or less transparent. It's explicit in order to create this universal set of rules that have to apply to the people of a certain country or context or municipality or whatever. They are collectively agreed and collectively questioned and criticized because of this public debate that is happening. On the other matter, when we talk about code, it's private actors that are defining this code. It's software and hardware builders who are defining the rules of this code. They unilaterally decide them in their board meetings and impose them, rules that are maybe completely arbitrary, concerning mostly their interests. And there is not necessarily a public debate, and in the case of proprietary software, it's very difficult to question it or to criticize it because it's not even transparent what is it, what are the rules that we are subject to. Of course, this can be improved through open sourcing software for increasing public debate on code, right? On code of the platforms that we are using every day and that we will be using more and more. But that's definitely an issue. In the case of contracts, yeah.
Quick question.
Sure.
Can you have a secret smart contract? Or does the secrecy have to happen off-chain?
I can get into that, but I think I would rather finish the 2 or 3 slides that I have, and I can get into that now, if you don't mind. So, the contracts, any contract that any real legal contract that we can sign now, regardless if it says it or not, even if they are not explicit, there are legal safeguards that law has. So if you are signing a contract under coercion, the contract is invalid. If you are under legal age, the contract is invalid. If there is no mutual consent, if you don't have the capacity, or multiple reasons, the contract may be invalid and not enforceable. Of course, when we are talking about self-enforcing contracts, we don't have such things. So the contract is enforced regardless if it was valid in legal terms or not. The contract is not checking your age or your capacity. The contract is not checking if you are being coerced in order to sign it. We can try to work around this. We can try to do cascade smart contracts that depend on safeguards, or federation of smart contracts that respect certain rules, but we still have nothing of that such, right? And these DAOs, these robotic entities, robotic without bodies, so it's not really robots, they're potentially unstoppable, which is good news for censorship, because they cannot be censored, but it brings many issues. Like, for example, who is liable if the DAO does something illegal? How do you regulate, how do you forbid a DAO to do something if the DAO is autonomous? And that's not even, it may not have a public creator, a publicly known creator. And of course, we have multiple issues in the real world, right? Like even if Jean I transfer him the cryptographic title of a smart car, I still have to transfer the physical car, because if I have the physical car in my garage and he has the key for it, okay, but I mean, who owns the car, right? Also, there is a transfer of physical car. There is the legal transfer, because the legal ownership of the car is still an issue. Of course, there is interaction with real-world organizations. Still, even if we have these weird smart contracts or DAOs, we still need to relate with real-world organizations somehow, which might limit this trustless or anonymous, pseudonymous approach. And of course, there are issues with respect with the state of the card. It may be faulty. It may have issues that the blockchain cannot predict. Right? So this context can bring, it has a lot of democratic potential, because it basically allows anyone to deploy their own techno-legal framework on their code. It can boost decentralized collaboration. It can even be a dream for libertarians. But at the same time, we wonder if it could be a dystopia in which inflexible or even totalitarian network governmentality, where everything is uh, coded in a very inflexible way is constraining our actions in a way that was unimaginable a few years ago, right? It can be kind of a decentralized panopticon where with things are transparent but very constrained. So it's mostly that, and now I'll be happy to accept questions, and I can start with yours if you want. So there are. So imagine that we create a smart contract that can only that with embedded data, for example, that let's start with the basic. The smart contracts are in the blockchain, right? So if I want to deploy a smart contract on the blockchain, you all have to have a copy of it. So then I cannot keep it secret from the people in the moment that I want to record it in all your computers, right? I could put data inside of the smart contract that I can only read a smart contract, but still it will be in my computer. It will be in the blockchain, so it will be in everyone's computers. So I can tamper with it. So hiding things inside a smart contract is like hiding things in an HTML of a page, which, okay, maybe the user doesn't see it, but in the moment that I see the code, I would see the data that is hidden. So it doesn't really make sense. You know, if
Right, that's why I was at, that was my question.
yeah, sure.
So, in order to be evil, you would have to hide the stuff off chain.
Oh,
That was exactly my question.
you don't actually require that because today's terms of use are sometimes Machiavellic and really evil, if you want, and no one reads them. The same way,
In that sense, sure.
in that the complexity of the code can be such that Yin, even if he knows somehow how to understand code, it will be so complex that he doesn't really understand what he's signing. I mean, of course, Yin might be reluctant to sign such a contract, but he's already in Facebook. I'm guessing. But you know what I mean? And the terms of use of Facebook. Of course, it's trying to provide more value to you than for you to still sign the terms of use, even knowing that they are disgusting, right? So.
So would you say that it's not really that democratic? Like, let's say we're trying to uphold this like blockchain technology to like, not only just banks and but into government as well. If you're not well versed in code, then it's not really like it's an asymmetric contract, right? So, like,
Well,
how would this be used further than just Bitcoin, which is what everyone's trying to do, right?
the thing is that the same argument we can use it with the terms of use. Terms of use can only be understood by lawyers. Any human that is not a lawyer cannot understand properly the implications of the terms of use. And yet, we are using them in every web service right now. So there is a inequality there in which only certain experts can properly understand the conditions in which we interact with an interface, right? And this is already happening today. The only thing is that now we would not only require lawyers, but also coders, because this is legal code or like something in between, because even a coder might not fully understand it because of the legal implications. So it might be the expertise required to understand the code that is governing our lives is suddenly much higher, right?
Yeah, so it seems to me one of the big problems you highlight is around this. I mean, the question of sort of disputes on what occurred when a smart contract executes, right? Like in the you hire me for GitHub example, if I write really crappy code, but it looks to the program like, hey, I committed all these things, I might still be paid, but frankly, the person that tried to hire me or that created the DAO probably doesn't like the code I wrote. And so do you think it's possible to like where you could like integrate a DAO or like the smart contracts within a legal framework or legal entity to sort of resolve when the disputes occur sort of in the legal side? So if everything goes well, the smart contract executes, both parties are happy, the legal side doesn't really have to do anything. But if when there is a dispute, the smart contract itself doesn't seem like it's really capable of renegotiating what already happened, but like a legal entity could do that, right?
So there are. Do you want to?
I had thought sort of along those lines, and it had to. At first, I was thinking about the problem of the fact that in current regular law, sometimes you leave a term uncertain because both sides just agree to leave it uncertain because otherwise they can't get the deal done. And so in your example, and then it got me thinking about another trust issue. For a service deal like the example here, what if there was an agreed on range for the service, and then the buyer could pay somewhere within the range, but then through the miracle of blockchain, if people's histories as buyers and sellers could be managed to weed out people who always only pay the bottom, or their the price they would have to pay would get pushed up. See what I mean? Anyway.
Yeah. So there are multiple solutions to this problem. So what we are talking about is reputation. So we can embed a reputation within this context. And in fact, the Ethereum people are actually building a reputation system on top of Ethereum. So you would know the reputation of a certain identity in order to hire the person or not, which is along those lines. You can also, if a smart contract code by itself cannot decide, it's fine. You can either rely on the crowd, people voting, if this is good or bad. You can rely on a third parties, like you can rely on an oracle directly. So you have an entity that is a judge, that is controlled by an institution, it's controlled by a person, it's controlled by a web service, it's controlled by whatever, but this oracle decides if this code is reliable or is not reliable, and that's it. You can depend on a third-party service, a DAO that provides verification. There are some attempts to do that with prediction markets. So people would bet for or against certain things, and this way it would take decisions. So there are different ways of dealing with verification. I don't know which ones would be more common because this is still happening as we speak, but I mean, certainly there are several ways.
I just quick, follow up. I think my question, or the idea I'm thinking of, it's potentially rather than setting it up directly as like this contrasting model, here's the legal side, here how things work today in law, and here's how smart contracts work. Given the things you're talking about, where you can bring in judges, you can bring in arbitrators and others, wouldn't we be able to possibly then design this hybrid model where for most of the cases where both parties agree and the outcome is generally positive, the smart contract executes, nothing happens. But then for those cases where there are disputes and gray areas and code is not really great at sussing that out, you bring in the human aspects and the legal frameworks and these other aspects into it.
Yeah, in fact, we are testing now technical governance and its limits, right? Mm-hmm. How far can technical governance go? And how much we have to introduce social governance because the technical cannot go beyond certain limits. We don't know what are the limits. but certainly we would need some trade-offs, some balance somehow, and put humans in the equation somewhere.
Yeah.
So
Sorry, I think. Thank you. So I guess I was wondering, what is the point of doing all of that? What is the motivation of doing all of that through the process of the blockchain, which is, sorry, I missed the first half of the presentation, but that is very hardware intensive in a lot of ways. So what does it guarantee us if we see all of these kind of shortcomings where individuals are kind of trying to suss that out in the process of, for example, ordering milk, right? So eventually the interface with the real world, as you suggested, you need to deliver a physical thing, and at some point you have all of these different entities that have to play their part in a legal, non-technical order, right? So the investment that goes into the added work of the blockchain, I'm wondering how does it account for itself?
I mean, there are multiple advantages. So, for example, for the Internet of Things scenarios, it's enabling, it's a technology that it enables use cases that were not possible before. So this playing field in which the fridge can talk with your phone and your microwave and the supermarket and buy and sell whatever is required, it's a benefit that this technology brings, and that it's better than other technologies in doing so. Also for
On that scenario, because I'm just wondering, like, that could happen. So I understand the idea of like an Internet of Things talking to each other and automated, right?
Yep.
Amazon has those buttons that
Yep.
are supposed to be filled, and
Yep.
then they will deliver it with a drone, so you don't even have to have a person that comes, right?
Yep.
So there are sort of more centralized models that would
Exactly.
still automate the process.
Yeah,
But I have to trust Amazon.
That's true.
Right?
That's true. The idea here is that we would have transparent interoperability onto systems that are decentralized from, I mean, of course, it's as interoperable as the manufacturers want to do them. So we could have the Samsung blockchain, the Amazon blockchain, the IBM blockchain, and not talk with each other. Or we could have a blockchain where different entities are talking with each other regardless of the manufacturer, right? I don't know in which direction we would go, but definitely you have this playing field. You have the value transfer. It's very easy to transfer value through the blockchain because the transfer of cryptocurrencies, it actually reduces the cost a lot than using a Visa card or a bank, if you understand what I mean. So for the transfer of value, it brings interesting options. For bringing a smart property onto the field, it also brings new potentials that were unexplored. For for this new way of contracts, it's also something somehow new. I mean, it's not as new as it could see, but definitely it boosts much more this approach of a smart contracts in which you don't need to trust the other person in order to sign an agreement together, right? It has a lot of drawbacks, but it can have potential benefits, definitely. I don't know.
I'm coming back to this question related to the interface between the blockchain environment and the law, especially state law. So, if I understood correctly, when you want to contract with a DAO, you have, as a human being, you have to accept the terms of use of that DAO. Now, you said that also exists in law, but I mean, the comparable element in the law would be boilerplate. And in every system of national law, you have rules that determine the conditions of possibility of boilerplate in order to protect users, for instance. So my question would then be, if there is an issue about terms of use of that DAO, how could you determine the jurisdiction that would, in a way, be responsible for clarifying these use? Because, I mean, that to know the jurisdiction is extremely important for the choice of law that then applies. Even if you have arbitration, you need to know first what the jurisdiction is in order to know what the law that can be chosen will be. Have you any idea of how one could approach this type of problems, interface between the blockchain and the real legal order?
Yeah, I mean, okay, we are talking about a technology that is transnational by, I mean, inherently transnational. So in the moment that, because of course we already have challenges of with normal servers and code that is running in different servers, that the companies on this, the company Google, right, that has data centers running wherever, but the user is here, and then user has this the nationality that is not in this whatever, and is using the computer, this specific computer from this manufacturer, and it's using Gmail that is taking it from a computer, sorry, from an American corporation, but the data centers are maybe in Sweden. So it still brings a lot of complexities with normal law and
but
normal.
courts have found solutions in
Sure.
many cases to deal with this type
Sure,
of
sure. No. I understand that law has been challenged by all this, and after some time has found ways of coping with this complexity. Some national laws better than others, right? So now we bring even more complexity because it's not this data center that is. We still have code that might be developed by Google or by whomever that is running in a laptop that I am here or there or whatever, but suddenly this code is replicated in all the nodes of a network that is inherently transnational. So I honestly don't know enough to invent a solution for that. I mean, this is a work that I have done with Primavera de Filippi, who is a lawyer by, I mean, she's
Just
into
to
law more than
explain
me. So
what I
Yeah.
was thinking about, I mean, the example of Google or Facebook, which creates a lot of problems regarding jurisdiction, but there still you have an organization, and
Sure.
an organization that has
Sure.
buildings, that has
Sure.
staff that are permanently working there, that need to travel in the country and outside. So it is possible to get hold of that organization. But doesn't seem to be the case with these DAOs. You said they are just in a way virtual. You do not know actually who is behind them. So
I mean, you can have DAOs that are representing a certain organization. Like GitHub could have its DAO, its official DAO, and then you still have an organization behind it, right? But of course, there can be DAOs that are not. And then we are talking more about a virus, whom owner or a creator you might not know, and it's somehow the virus is spread all over and causing harm around. How do you regulate a virus? Well, it's complicated. It's actually complicated. In the same way, you have this DAO that is there deployed. It may have an organization behind it, or a public human behind it, or not. And the problem of this is that you cannot limit a single DAO without limiting the whole infrastructure. So
Say that again?
you cannot limit one single DAO. Like imagine that more and more we start using the Ethereum blockchain, and a lot of people use services on top of Ethereum, and suddenly we have a horrible DAO that we want to switch off and cannot. The only way to do that is to turn off the whole Ethereum blockchain. The same way that in order to censor the internet, or you censor the whole thing, you cannot censor a part. Here it happens even more exaggerated. Right? I mean, of course, you can forbid people to code DAOs in certain way. Like by law, all DAOs have to have a kill switch. So they are all, we can all kill them. Or by law, all DAOs have to have an identified owner. And then you are limiting the code that you can write. But of course, still people could write the code and deploy it, disobeying that law, and the code would be there, right? There was...
Right, you couldn't enforce that. One can easily imagine benign DAOs that pass on the validity of other people's contracts. And I wouldn't sign a contract with you unless it were affirmed by some DAO that I trusted, that said, oh, the terms are like this, and the paying groups will agree to this, and they'll agree to his authority. And by the way, some appropriately constituted legal authority can come in and turn this off, kill switch, or change the terms of it, or at least investigate it and so forth. One can easily imagine that, but nobody has to use that. I mean, like second slide said, and the second thing people do with code is get around other people's code, or invalidate other people's code, and that. So we have a situation here that is where there's a certain legal set of benign DAOs, nice polite ones that have good behavior, and then we have the Wild West, exactly as we have darknet today, for example. I mean, where people can make contracts for anything. You know, this is just a highly automated version of that you could not shut down. Is that approximately correct?
I mean, I think it's a good approximation of what can happen. I don't know though if because nowadays the dark net is something that most users don't use.
Right.
I don't know what would be the norm here. If the Wild West would be the norm, or if, you know what I mean?
Oh, yeah, right.
Or if a civilized environment, which with a lot of safeguards, where we have clear icons identifying what protections you have when signing that contract. I mean, we don't know where it will evolve, but definitely we can. The same as we have. I don't know if you have heard about the privacy icons way of like badges for cataloging the terms of use. So I would see the terms of use, and with a few icons, I would know if it's selling my data, if it's giving it to authorities without informing me or stuff like that, without me needing to understand the legality of these terms of use. The same way we can think of smart contracts being identified with some badges, with a benign DAO giving you some advice if this is something that Yin should sign or not, right?
Are such icons just a shorthand for the paragraphs of boilerplate in license agreements that we all skip over?
Yeah.
So there would
Yeah.
just be abbreviation for that.
Yeah.
So I look at the set of icons
Yeah.
instead of reading.
Yeah. But of course, here it's quite complex, right? Because either humans read the code of every DAO, or we have automated processes to understand that this code is doing this thing and whatever. So we had, anyway, I'm a bit lost who wanted to talk about it.
Actually, did you have a question? I know you've been raising.
Oh, I'm so sorry.
You just mentioned the financial world. Use the blockchain.
The what?
But financial world.
The financial world, yeah.
You use blockchain to like mine things, the black coin, black coin. You use
Bitcoin.
Bitcoin, yeah, yeah, yeah. Black,
black coins, black coins.
black, I don't.
Bitcoins.
Bitcoin.
Ah, yeah,
Bitcoin. I'm sorry.
yeah, yeah.
Used in all over the world. But in my understanding, it's different from the every country's currency. It's just like you play in a casino. You use chips, right? So the chips is valuable in this casino. But outside the casino, every country has their central bank. You mean the tendency is their central bank will disappear one day if everybody.
Oh, I'm not. I don't know what would be the future, but definitely.
Because everybody self-control, self-enforcement, the law, because the code is law, which means in financial world, the central bank will disappear.
I mean, right now, instead of disappearing, they are experimenting with this technology. So the amount of investment from the with the fintech hype,
Yes.
the amount of investment that banks are putting into the blockchain is tremendous. Not so much for having bitcoins for everyone, but still they are exploring the potential of this for many financial assets. And even for sharing information in a trustless manner within the banks. And for, of course, for transfer of value, it's a very efficient and transnational way. You do have commissions here, like you have with banking system, but of course the commissions are ridiculous compared with, like, you can increase the commission for your transaction to be processed faster by the miners, basically. So I think the metaphor of the casino works somehow. You can talk about this as a toy coin, no? It's like, yeah, like the geeks are having fun playing around with toys and casino chips. But actually it's getting bigger and bigger, and bitcoins are being accepted more and more by actual services. And in the moment that you can buy and sell and change it as any other currency, actually we are talking about an actual currency in the end. So we have here and there.
We just have like 3 minutes left. So.
Right, so what is your opinion on private versus public blockchains? Because any person can replicate this technology and kind of duplicate it on their own system. Should we have one where we can have all these contracts be decided upon, or should kind of individual organizations kind of build their own blockchain on a case-by-case basis?
Okay, there is a lot of debate there. I mean, we have an approach in which side chains would be like, okay, one of the main technical problems of this is scalability. So scalability of this technology is an issue, it's a technical issue that is still yet to be solved. So many people argue that instead of having the one and only blockchain that would have all the smart contracts in the world, kind of as Ethereum approach, that we would need multiple interoperable blockchains for different use cases. We can have, of course, multiple chains that are not interoperable, and this is a disastrous scenario from my point of view. The fact that we have one and only blockchain or multiple blockchains that are interoperable, honestly, I don't care much. As long as there is interoperability and decentralization through the whole ecosystem, I'm fine with that. And as long as there is no one single actor controlling everything that is happening, of course. Because one of the largest potentials of this is to replace the centralized cloud infrastructure with a decentralized ecosystem. And this brings a lot of benefits. So in order to keep these benefits, we should handle either there is one blockchain that is not controlled by a single actor, or there are multiple blockchains that agree on an interoperable way of interacting with each other, so we don't need to depend on one or the other. So we had that there, that I interrupted you, but he didn't talk, so.
No, whether
It's okay.
it's time. Just one additional information. I think that one of the reasons why the banks are so much investing money into further developing blockchain is also because they are scared. They are scared of losing their business model. And another point, you said it has become also part of the real world. An example is the government of the canton of Zug in Switzerland, which is a hub for blockchain and Bitcoin technology development. That government actually recognizes Bitcoin as money. It changes
I didn't
Swiss
know.
francs into Bitcoin.
Well, on that note, thank you for coming.
Thanks a lot.
Thank you everyone for coming. Yeah, that's great. Yeah, no, and it was really informative. I mean, I remember reading the paper, so it was really good to also